if you look at your formula sheet, we used the kinematics equations when we did the acceleration problems. And you had this formula of x equals v naught t plus 1/2 at squared. When we start talking about free fall and things falling, instead of having this x component, because that was horizontal, we're going to change that to y. And we're still going to have our v naught t plus 1/2. And instead of saying a, it's really going to be our acceleration due to gravity. Okay, so you might see it written as y equals v naught t plus 1/2 at squared, or you may see it written as y is equal to v naught t plus 1/2 gt squared. And when we do free fall problems, we're just replacing a with the acceleration due to gravity, which on Earth is equal to negative 9.8 meters per second squared. This will be on your formula sheet, but you probably already know that number. Your textbook used it as 10 meters per second squared, but we want to use a more accurate number and say 9.8 meters per second squared in these formulas. All right, so for our first problem, how far will a rock fall in 6 seconds if it is released from rest? Okay, so we know some of the things in this problem. We know the time is 6 seconds. We know that our acceleration due to gravity, a or g, whichever one you want to use, is going to be negative 9.8 meters per second squared, and it's released from rest. So our initial velocity is going to be 0 meters per second. And sometimes this v naught you may also see as v naught y, because this becomes a initial vertical velocity. So you may see either one on a formula sheet, okay? So because it's falling vertically, we now consider it a v naught y, okay? So this is our v naught y. And what are we trying to find? We want to know how far it's going to fall. So we're trying to find its vertical displacement. That's what we don't know. Look at your formula sheet and try to determine which formula we should use to solve this problem. All right, if you look at the formula sheet, you probably have y is equal to 1/2 gt squared plus v naught y over t. Sometimes, it's because you have 4 different teachers teaching this, you might have one of us write it this way. Y is equal to v naught yt plus 1/2 gt squared. It's the same thing. We've just switched each component around, and it's the same thing. Remember, in these free fall problems, we've replaced the a from your kinematics equations with g, and we will always plug in negative 9.8 meters per second squared for g. Okay, so your first step on these problems is to always write down the formula. Or after you write down the formula, you want to show your work. So if you would go ahead now, plug in the numbers that you have for this problem into the formula. Once you've plugged in all your numbers in the formula, it should look like this. Y is equal to 1/2 times negative 9.8 meters per second squared. Remember, you've plugged in g on Earth, acceleration due to gravity, as a constant, negative 9.8. Your time, don't forget that this time is squared, 6 seconds, the quantity squared, plus, remember your initial velocity, it was from rest. So this is 0 times your time is 6 seconds. So if you look at this, you can notice 0 times 6, it's going to be 0. So this quantity right here basically cancels out, and you're only left with that first half of the equation. All right? Why don't you do that math and see what answer you come up with? When you look at this, you're left with half of 9.8, or negative 9.8, which is negative 4.9 meters per second squared. And when you squared your time, you also squared the units. So 36 seconds squared. Okay? So if you look at this problem, it makes it really nice because second squared here is in the denominator and second squared here is in the numerator. So these units actually cancel each other out. So you're left with your answer, y is equal to negative 176.4 meters. You're probably asking yourself, why is y negative? Now, Remember, vertical displacement is a vector quantity, so it has to show direction. So this negative sign is merely showing direction, that it's falling in the downward direction. If you're uncomfortable with that negative sign, you could also say 176.4 meters down, okay? So circle your answer or highlight it, underline it, something to make it stand out. But for every problem, you should show your formula, show the work, and the answer with units. Also, if you're just starting out, it's a good idea to list, like I did at the beginning of the problem, list all the variables of your knowns and your unknowns. Okay, second problem. A ball is thrown down at an initial velocity of 18 meters per second. How far will it fall in the first 4 seconds? Look at your formula sheet and try to determine what formula you're using. But first, I would write down the variables that you know and what's unknown. So do that first. All right, you should have listed this. The initial vertical velocity is 18 meters per second. What says initial velocity? You know it's sort of down, so it's going vertically, okay? The time is 4 seconds. We know g, the acceleration due to gravity, is negative 9.8 meters per second squared. And we're trying to find how far it's going down. How far is it falling? We want to know the vertical displacement, okay? So look at your formula sheet and let's decide what formula we're using. All right, if you chose the same formula again, you're correct. Y equals 1/2 gt squared plus v naught y times t. Okay, so let's plug everything into this equation. Okay, one thing I want you to think about is realize this is thrown down at an initial velocity. So in order for me to show direction, but something's traveling down, you've got to put a negative in front of this 18 meters per second. It is being thrown down in the downward direction. So you have to represent that so we know that in the problem. So let's plug everything in. Y equals 1/2 times negative 9.8 meters per second squared. All right, this is what you should have. Y is equal to 1/2 times negative 9.8 meters per second squared times 4 seconds quantity squared. Don't forget to square that time. Plus negative 18 meters per second times 4 seconds. All right, try doing the math. So you should come up with negative 72 meters plus negative 78.4 meters. And when you add this together, you should get negative 150.4 meters. That is your vertical displacement. The negative sign's there because it's showing the direction. Remember, it's a vector quantity. Okay? So check your work. Make sure you did that. So let's try this last question. A ball is thrown up at 22 meters per second. What is its displacement above the ground in 2 seconds and in 4 seconds? All right, I'm going to pause this so that you can list your variables of your knowns and unknowns. There's really 2 problems here. And then I want you to write down the formula, put everything in, and then try to solve it to see what your answer is. Go ahead and try that. At this point, you should have your variables listed and your formula written down. So V naught y here is 22 meters per second. Is it positive or negative? Well, if you're throwing the ball up, okay, that's a positive direction. So this is going to be a positive 22 meters per second. And then the times, 2 seconds for your first problem and 4 seconds for the second problem. So you're really doing 2 problems here. And then g is negative 9.8 meters per second. And we want to know its vertical displacement above the ground. Okay, so we want to know how far it's gone up in the positive direction. So should your answer be positive or negative? Yes, you're correct. It should be a positive number for your answer. I want you to plug the numbers in and try to solve for both of these problems. Okay, for the first problem, 2 seconds, plugging everything in. Y is equal to 1/2 negative 9.8 meters per second squared times the 2 seconds squared plus 22 meters per second. Remember, that's positive, times the 2 seconds. And notice how nicely these second units cancel out. This second is in the numerator. This is in the denominator, so they cancel out. Same thing here. Second squared in the numerator, second squared in the denominator. They cancel each other out. So over here on the left, we're left with negative 19.6 meters plus over here 44 meters. We add those two up, 24.4 meters is how high it's gone up. Is it supposed to be positive? Yes, it's supposed to be positive for that one. Now I want you to use the second problem with the 4 seconds. Try that. All right, when you look at this one, you're plugging in. All you change it is the time. So now you're plugging in 4 seconds in here. Don't forget to square it. And 4 seconds here. So on the left, it's negative 78.4 meters. And on the right, it's 88 meters. You add those two numbers up, and your vertical displacement is 9.6 meters. So this time, the longer time, it's gone a shorter distance in the air. Okay? So those are your 3 problems. Now we'll do some more practice in class.